Establish application security. Users in your organization can access several Internet communications applications, including web browsers and email. In some cases, users may also be running instant messaging IM and peer-to-peer P2P types of applications that should not be running on a corporate network and typically serve no purpose in a work environment. The following sections describe IM, P2P, and other types of applications and procedures to help you make sure these applications are running in a secured manner. Web application vulnerabilities. As programmers had increased functionality to websites and web browsers, the potential for security vulnerabilities increases. The biggest danger is the tendency toward integrating the web browser functionality with other computer applications and even the OS itself. This means if a web browser security vulnerability is exploited, an unauthorized user has access to the core system files and data of an authorized user's computer. The following sections outline some of the more popular web application components and the security vulnerabilities they might create. JavaScript. JavaScript is a scripting language created by Netscape, but it is unrelated to the Java programming language. JavaScript's code is not compiled. Instead, it is interpreted by the web browser. JavaScript can interact with HTML source code, enabling web authors to create websites with dynamic content. Since the introduction of JavaScript, the language has been plagued with security issues. The problems originate from the nature of JavaScript, which allows executable content to be embedded into web pages. These vulnerabilities include the ability for hackers to read files on a user's hard drive and to monitor and intercept a user's web activities. Security precautions are required to prevent malicious code from entering, executing, and retrieving data from the underlying system. The insecurities of web browsers that implement JavaScript, rather than the JavaScript language itself, are the source of the vulnerabilities. Most security problems discovered in JavaScript implementations require the installation of software patches from the web browser vendor. JavaScript can also be disabled on your web browser. Check the browser's options to disable or enable the use of JavaScript for websites accessed by users. Java. Java is an object-oriented, platform-independent programming language created by Sun Microsystems. Java is typically used on Internet websites to provide small programs, called applets, that can be downloaded to a user's web browser. Because Java is platform-independent and can't run on any type of machine or OS, it requires the use of a Java Virtual Machine (JVM) to convert the program to the code understood by the local machine or OS. Java programs run in their own special areas, called a sandbox, which restricts the applet's access to certain parts of the computer system. This prevents malicious or buggy software from accessing critical parts of your system. Hackers, however, are able to program applets that can bypass the security features of the sandbox and access the data on a user's hard drives. For added security, most web browsers can be configured to allow only certain access privileges to Java programs. Signed applets. Signed Java applets are programs that are authenticated through the use of a digital signature that provides information on where the applet originated. The web browser reads this signature and checks to determine whether it comes from a known, trusted source. This allows an applet to have fewer restrictions applied to its operations than those of a normal unsigned applet. An authenticated signed applet is usually given more access over OS functions to performed operations. ActiveX. ActiveX is a technology created by Microsoft to create reusable components across Windows and web applications. This includes increasing the functionality of Internet applications. Similar to components created with Java, ActiveX components can be downloaded to the computer through the web browser. Unlike Java, which has software controls that allow programs to run only in a certain area of memory and influence, ActiveX functions are controlled by the users themselves. This requires the need for greater security controls because a malicious ActiveX component can be downloaded that could compromise the security of your system. Users must be careful when configuring their web browsers to control ActiveX programs. Note that ActiveX controls run with the same permissions as those used by the user currently logged in. For web browsing security, ActiveX uses a form of authentication control based on security levels. The user's web browser can be configured to set a certain security level at which ActiveX controls can operate. The lowest level allows all ActiveX components to be downloaded automatically. Increased levels provide warning dialog boxes to alert the user of an ActiveX element and enable the user to download it or not do so. ActiveX relies on digital certificates and trusting certificate authorities to authenticate the origin of ActiveX controls. As always, your web browser should be updated to the latest version, so the most recent security controls are in place and any previous security vulnerabilities are removed. Many people, in the interest of higher security, disable some of the advanced web browser functions, such as downloading ActiveX and running Java applets. Unfortunately, many websites require these to perform even the most basic functions, and if you disable these functions, you might be unable to access the site. Try to maintain a balance between convenience and security. Input validation. Input validation refers to the process of coding applications to accept only certain valid input for user-entered fields. For example, many websites allow users to fill in a web form with their name, address, comments, and other information. If proper input validation code has not been included in these types of web forms, in certain cases a malicious user can enter invalid input into a field that may cause the application to crash, corrupt data, or provide the user additional unauthorized system access. Invalid input often leads to buffer overflow types of errors that can be easily exploited. Encoding proper input validation within an application reduces the risk of a user inadvertently or intentionally entering input that can crash the system or cause some other type of security concern.